Hello everybody, this is Quantum Gimmick, and today I'm here to show you how to use the M1015B analog multimeter. Plus, I'll be giving you some tips on getting the most out of this little gem. Are you here looking for something specific? Click on any of the following annotations on screen and you'll be taken to the relevant clip. Otherwise, let's move on. The newest design has the red port color-coded, so there is no doubt where the red and black leads go. But in the older versions, this was not a consideration. The general rule for multimeters is that the black lead always goes into the COM or common port, as shown here. Sometimes this doesn't even matter, but when it does, I will show the following sign indicating to pay attention to the polarity. First things first, make sure your needle is at 0. If it's not at 0, adjust its position by turning that big plastic screw below the screen. When your dial is turned to any resistance setting, crossing the leads should give you a 0. If this needs adjusting, use the wheel on the side of the multimeter. Work around the house often requires you to work with AC current. Things like doorbell transformers and wall outlets all run on AC electricity. First, let's check out the outlets. Well, we should be cautious of these since they pack 120 volts, at least here in the United States. We can still safely measure them. Since we are expecting 120 volts, the 250 range will fit our purpose. Now that we chose the 250 range, this section I'm highlighting is the one we will be using to get our reading. And at 120 volts, we expect to see this. Measuring from this extension cord, we can see the needle jump close to the middle, giving us our 120 volt measurement. The good thing with AC voltage is that if you measure the opposite way, you'd still get the same result. A common doorbell transformer, like this one bought at the Home Depot, runs on AC current. Since the transformer is rated between 8 and 24 volts, the 50 range is enough. And this time, we will be focusing on this range in the middle. I'm going to measure the two bottom leads, which are advertised as 24 volts, but as we can see here, it's closer to 29. And that's how you measure AC voltage. DC current is the electricity you get from batteries or wall adapters, which transform the AC from the wall to DC for your electrical appliances. Keep in mind that measuring voltage is actually measuring the difference between a higher source, color red, and a lower ground reference point, color black. So what does this mean for you? Basically, don't reverse the leads or you'll end up with a reverse measurement. We'll be measuring a universal adapter at 24 volts, so the 50 range should suffice. On the screen, we'll be focusing on this middle range. The multimeter measures between 24 and 25 volts. Despite the adapter indicating 24, the voltmeter agrees with the multimeter, a testament to the multimeter's accuracy. I advise caution with the following phenomena. While not exclusive to batteries, it is more pertinent to them. Notice the voltage when not in use, with no load. Now notice the voltage when in use, while under load. Notice how the voltage spikes back up when I turn off the circuit, and how the voltage of the battery has deteriorated with use. You may want to consider these phenomena as they may affect your work. With our multimeter at the 10 volt range, we will measure this brand new 9 volt battery. Since it has no load, we should see something higher than 9 volts. And as expected, we read 9.5 volts. And that is how you measure DC voltage. The number one rule when measuring resistance is to always turn off the circuit. Otherwise, you'll get a reading that's way off, and in worst case scenarios, you'll damage your multimeter. Measuring resistance with an analog multimeter requires very simple mental math. If we have it on the 10 volt setting, and we measure a 1, it means we have 10. If we measure 20, it means we have 200. If we put it on the 1000-volt setting and we measure a 2, it means 2000. If we measure 50, it means 50,000. It's that simple. For this demonstration, we'll be using the 10-volt setting, and we'll be looking at this top green section for our coefficient to multiply. To measure resistance, we put the leads on both ends of what is being measured. It reads 10, so therefore this must be a 100 ohms resistor. And according to the markings, we'd be right. For our next example, we'll be using the 1000-volt setting. And upon measurement of the resistor, we get a 20. Therefore, this measures 20,000 ohms. Upon checking the resistor, once again, the manufacturer agrees. This analog multimeter only measures DC current safely. Do not, under any circumstances, measure AC base current unless you enjoy the idea of second-degree burns. Measuring current is unique in that you first have to break the circuit, then insert the multimeter into the circuit, and then have the circuit live in order to get a measurement. Sounds complicated, but it's actually really simple. Here is the simple circuit: the LED, the limiting resistor, and the 2 poles of the power source. Very basic. First, we'll use the highest setting of 250 milliamps. Then, I'll put the leads between the source and the resistor, completing the circuit. Looks like we have movement, but it's too small for me to read. So I'm going to use the next setting of 10 milliamps, and we'll read from the lowest range. So now, we'll complete the circuit again, and now we have something. It looks like we got around 5 milliamps. And that's how you measure DC current. Here I have a depleted battery, a used battery, and a full battery. With these, I will show you what you can expect from the battery testing option. First, I will set the dial for the 9-volt battery test. Now to test the depleted battery. Low on the scale as expected. Now for the used battery. In the green, but just barely. Now for the brand new battery. A test for the 1.5 batteries is also available and works just the same. A decibel is 1/10 of a bell. A bell is a logarithmic unit that is used to express ratios. So if we amplify the signal by 10, we go up plus 1 bell. And if we amplify it again by 10, we go up 1 bell again. This saves us the hassle of dealing with ratios. Now, in practice, we use 1/10 of a bell, the decibel. Since our hearing is logarithmic, to double music intensity, we simply add 3 decibels of amplification. Basically, the decibel is a shorthand system for real-world complex measurements. Now going back to the multimeter, most tutorials skip this function completely, and with good reason, and that you won't be using this function. I personally could not find any application in my house or workshop which both 1. Used step-up amplified AC voltage, and 2. Would even make sense to measure in decibels. So hope this gives you a vague understanding of this function and why other tutorials usually avoid this subject altogether. More costly digital multimeters, like this one I have here, have an audible continuity function that makes a sound when there's an uninterrupted connection. Our analog multimeter does not include this option, but we can still test continuity. We can do this by simply setting the multimeter to any resistance setting, and if the needle reaches the far right, you have a solid connection, as shown in this example. This is useful in identifying things like broken line cables and blown fuses, since they won't make a continuous connection, as shown here. Here, I replaced the fuse, and now the multimeter detects continuity. The continuity test is one of the most used functions in electronics, as it makes identifying problems fast and easy. The most common question people have about these multimeters is how to replace a blown fuse. I recommend opening the multimeter and taking the fuse for reference when shopping for a replacement. Fuses are usually sold in two sizes. You'll want to buy the shorter type of about 3/4 of an inch. It should break at 500 milliamps and handle 250 volts. If you go to Radio Shack, ask the associate for this item number. Here is the original fuse for comparison. If you go to Home Depot, ask the associate for this item number. As you can see, this one's different from the original in that it's made out of glass. But don't worry, most multimeters use glass fuses just fine. One of the advantages of analog multimeters is that they don't need batteries for most functions. As you are about to see, even without a battery, this multimeter is capable of measuring DC voltage. The only functions that are lost are resistance and continuity. However, advanced users can use Ohm's law to find the resistance. In short, when all else fails, your multimeter won't. Hope this tutorial helps. If you have any questions, leave them in the comments section below and I'll try to answer them to the best of my abilities. This is Quantum Gimmick, signing off.